Hi everyone, it's Bob Crossan. I'm the editorial director for Wastewater Digest. I'm joined today by Nick Guho. He is lead technologist for Carollo Engineers. Thanks for chatting with us today, Nick.
Absolutely, Bob. Excited to be here.
Yeah, so we wanted to talk about machine learning, specifically in clarifiers.
Sure.
Could you talk to me a little bit about how machine learning is different from some of those traditional empirical models that people have been using?
Absolutely, yeah. So empirical models, we've been using them for 40 years or so to predict the performance of primary clarifiers, specifically TSS removal. And those empirical models that we've used have been fixed in their structure. So they are algebraic relationships that are relating the main operating variables that we've identified. So it's surface overflow rate, HRT, influent TSS concentration, relating those variables to TSS removal in primary clarifiers. Machine learning models, relatively new on the scene, and they differ fundamentally from those empirical approaches that we've used in that the structure of the model itself is flexible. And so it becomes, in a sense, a parameter in the model that you can tweak to improve the overall fit and accuracy of your model predictions. The other benefit to machine learning models is that it's a lot easier to incorporate different operating variables into the relationship itself. So we can bring in BOD, we can bring in COD, we can bring in day of the year as an example. And the idea behind doing that is that those variables are indirect measurements of the underlying variables that we don't measure that dictate primary clarifier performance. And by using machine learning models, those models are able to pick up on those underlying relationships and then capture those underlying relationships and improve the overall model fit. And so what we're finding in general is that the machine learning models do perform a little bit better than the empirical models that we've used historically. Granted, it's a minor improvement, but it is still an improvement, and it points to a lot of promise in this area in the future to try to improve it further.
Yeah, so you mentioned some of the benefits there. What would be some of the significance, say, for a utility professional, someone working at a utility, or someone in your position who's, an engineer working in the field?
Sure. So what we're using them for primarily is in our facility planning and capacity evaluation perspectives. And so in that area, what we're trying to do is predict primary clarifier performance, often under conditions that the primary clarifiers historically haven't seen. So these are looking at future flow and load conditions. And that makes it really difficult to predict performance because we don't have that historical basis to go back on and look at, okay, well, it's performed this well in this period, and so we can then extrapolate and say that it's going to perform that well. The machine learning models, we're using them primarily in concert with the empirical models that we've used historically to build kind of an ensemble representation of different predictions of performance under those future conditions and build a consensus of how things may perform in the future. And so the benefit to utilities and process engineers like myself is that we'll have a much wider sense for how those primary clarifiers may perform in the future and different sources that we can point to that are supporting, ideally, that performance in the future, and then we'll be able to improve our overall model predictions as a result.
Yeah, so if we were to dig into some of the specifics more, are there specific things that you can talk to when it comes to these machine learning models? Like if a utility was like, oh, I'd really like to try this one, are there ones that you would point them to?
So absolutely. So machine learning is an ever-evolving field, certainly, and it seems like all the time we've got new models that are coming out, new techniques, improvements on existing techniques. What we found in our work thus far is that neural networks seem to perform the best in contrast to like regression trees, although many of the machine learning techniques do perform well and do perform about the same as or even better than the traditional regression approaches. So in terms of having a utility actually apply those techniques, there's a number of open source packages that are available that make it relatively easy to get up and running. There is a significant learning curve, or there can be, depending on the experience of the utility for software development, data analysis, or statistics. But Carollo, of course, would be happy to help with any sort of data analysis or modeling exercise.
Awesome. Well, thanks so much, Nick. It was great to chat with you and learn a little bit more about this. I know machine learning, I'm seeing it used in so many other things, and this was one where I was like, I've not heard of it in primary clarifiers before, so I was really interested to hear from you.
Absolutely. Yeah, this was a great talk.
Yeah. Well, and for everyone else who's watching, check out our video description below. We'll have some links to some other resources that you can check out down there, as well as some other WEFTech videos.